Hi guys. This next video, this is video number 8, and it covers a lot of material. So it's going to cover chapter 2, sections 2, 3, and 4, which is the entire rest of this chapter. So there's I have a page of notes per section, but they might take a little bit of time. I just want to make sure I prepare you adequately and give you enough examples. So this first one, this covers 2.2, and this is called evaluating functions. And just as a quick reminder, we talked about f of x, meaning that you have a function in terms of x. We also talked about domain and range. And we talked about how to tell if something was a function by having all unique x values. Okay, so in this one, evaluating functions, what you're actually doing is substitution. That is the big word. You learned how to do substitution way back in your math career. But this is just an upper level way. This is an upper level method of substitution. So when you hear evaluating functions, that's what I want you to think is substitution. And so here's how this is going to look. You're going to be given a function in terms of f. And by the way, this letter right here doesn't have to be an f. You're going to see g of x, h of x, all sorts of different little things because they have to be able to tell the functions apart from each other. So if you're told that f of x is 5x plus 4, and then you're asked to find the following. This is how a question in varsity is going to be worded. You're going to be asked to find f of 2. What that means is that wherever there's an x, you're going to substitute in the number that they replace the x with. So you're going to do the same thing on this side. Wherever there's an x, you're going to replace it with whatever the value is. So 5 times 2 plus 4 gives you 10 plus 4 gives you 14. And that would be f of 2 equals 14. Okay, if you're asked to find b, what is f of 0? Well, that means you're just going to plug in the 0 wherever you see an x. So 5 times 0 plus 4. Anything times 0 is 0, right? So this is 0 plus 4, and that equals 4. Seems pretty straightforward, right? It is pretty straightforward. This is not a difficult concept. So as these get more complicated, when we get to D and E, don't make them any more difficult. They're not. So this one, f of negative 3. The biggest problem I find with my students is not really knowing how to do actual basic math and order of operations. The negatives and minus signs get you into a lot of trouble in the upcoming math. So just be careful when you do these. So here, we're going to put a negative 3 everywhere there's an x. So 5 times negative 3 plus 4. 5 times negative 3 is negative 15, plus 4 is negative 11. The answers can be positive, they can be negative, they can be fractions, they can be 0. Sometimes they might not exist, so we might see an example of that as well. D, f of a. Well, this doesn't change. Just because I now have a letter in there, don't let that mean anything different. You're going to put whatever is here where the x was. So this is going to look like 5a, because that's where the x was, plus 4. And in this case, you have an expression as an answer. This is your answer. So let me tell you a little shortcut. so that you kind of have an idea. If you have a number in here, you're going to have a number for an answer. You have a number in here, number for an answer, number in here, number for an answer. If you have a letter in here, you will have an expression as your answer. Always that will happen because there's no way for you to make it any simpler. So if you have a variable in the parentheses, then you will have, oh, that was you and will all together. You will have an expression as your answer. Okay, so that's just something for you to keep an eye on as you go forward. The next problem will be similar. I'm going to write it down here, and then I'm going to scroll down a little bit. I'm finding f of a plus 6. So now I'm plugging a plus 6 in anywhere there's an x up in the original equation, right? So I have 5 times the quantity, a plus 6, that's where the x was, and I have to make sure I bring down the plus 4. Okay, so now you're just going to do that math. We're going to distribute the 5. So we're going to have 5a plus 30 plus 4, and then combine any like terms, 5a plus 34. And there is your answer. The answer is an expression because you have a variable in here, right? So I don't want to keep saying the same thing, but I do because I've been teaching this for a very long time. This is year 20, and I know where my students struggle, and this is something they struggle with. So I'm trying to take some time and be a lot more specific when I'm teaching these things so that you have a better understanding and clarification of what's happening. So that's kind of the intro. Remember, again, I can't emphasize enough that all you're doing when you're evaluating functions is substitution. That's it. And then simplifying. Okay? So bottom of your page, I don't know if you're on the left or right hand side of your page. I'm going to go to another page, and this is still 2.2. All right? So this is 2.2 continued. If you are given, now here you're going to see a couple different expressions. F of x equals x squared plus 2x plus 1. And g of x equals 3x minus 4. So these are just different f and g so that you can determine those functions. You're asked to find the following. And this is how this will look for you. F of negative 2. Well, that means choose the function that has an f in front of it and plug negative 2 in where all the x's are. So we're going to have negative 2 squared plus 2 times negative 2 plus 1. Well, negative 2 squared means negative 2 times negative 2, right? This is where most of my students, 95% of you, don't know how to use a calculator. And if you just punch negative 2 squared into your calculator and get negative 4, that's you not knowing how to use a calculator. You need to put parentheses around a negative number when you want to square it, or don't use a calculator and just know that negative 2 times negative 2 is a positive 4. Then this term gives you a negative 4 plus 1. These cancel each other out, and this equals just 1. Okay? What if you have g of negative 2? Well, that means go to the function that starts with a g. So that would be this one. And you're going to plug negative 2 in to this function right here. So that's going to look like 3 times negative 2 minus 4. 3 times negative 2 is negative 6 minus 4 is negative 10. Okay? What if you see something that looks like this guy? F of 4 minus g of negative 1. Well, that means you're going to evaluate this f of 4, So let's do that. That means we're going to put 4 into this function up here. Let me go back. I'm going to just make this very clear so we have a couple of, if I have any people that are confused. My function f is this guy, x squared plus 2x plus 1. Oops. And we're going to find f of 4. So we're going to put 4 in here, and then evaluate. Then we have minus from the problem over here. And then g of -1. Well, g is 3x minus 4. And we're going to find g of -1. So we're going to plug a -1 in there. And so here's how this is going to look. We're going to plug a 4 into this guy on the left-hand side. So we have 4 squared plus 2 times 4 plus 1. And I would keep this in parentheses or brackets until it will make your minus signs work better. Until you get a little further along. This is going to be 3 times -1 minus 4. And now we're going to simplify. Remember, order of operations. Parentheses, brackets, those happen first. So this is going to be 16 plus 8 plus 1 minus -3 minus 4 is -7. This is why this set of brackets is so important, because now you're going to have minus a negative in the next step, right? Which makes that a positive. So now 16 plus 8 is 24, plus 1 is 25, minus a -7, which gives me 25 plus 7. And I'm laying all these steps out so that you see every single step here. 25 plus 7 is 33. And so f of 4 minus g of -1, -1 equals 33, right? That came from the problem. This is us working those out in all those steps. All right, the next one that I want to take a look at, I'm going to actually copy this stuff up here. Let me see if I can get this in some. I'm going to group all that together. Then I'm going to copy it. Oh, lordy, undo that. Sorry, folks. All right, I'm going to copy. I'm going to go to a new screen, and we're going to paste, hopefully. All right, so there's our functions. There's what we need. And here's the next question. It looks like this. What is 2f of x minus 3g of x? So this is very different. This is not what this is. Not f of 2 minus g of 3. This one would have substitution when the number is in the parentheses. That's not the case over here. All this is saying is take the number 2 and multiply it by the function. Take the number 2 and I wrote the wrong thing. And multiply it by the function f of x. This guy. X squared plus 2x plus 1. Right? Take the 2, multiply by the function. So I would distribute. So that's 2x squared plus 4x plus 2. And then I'm going to subtract. So back up in my original problem, 2f of x minus 3g of x. That's what I'm going back and looking at. Now I'm going to subtract 3 from g of x, which is 3x minus 4, and take this -3 and distribute. So I have 2x squared plus 4x plus 2 minus 9x plus 12, and then simply combine like terms. So 2x squared, that one's used. 4x minus 9x is minus 5x. Those are used. 2 plus 12 is plus 14. Okay? So if the number is out in front of the parentheses, it quite literally means just multiply by it. All right. And here's one more example for this section. Let me see if I can paste again. I have to get my shortcut menu here. It's not popping up for me. And I don't have a mouse, so. Oh. Let's see if can I copy somewhere? I don't know. I'm sorry, this is taking up all of our time. Let's erase all that. Maybe I'll just rewrite them again. Erase. Okay. Ah! Well, let's just rewrite. I was going to copy and paste, thought I would save myself time, but given f of x equals x squared plus 2x plus 1 and g of x equals 3x minus 4. This time what you're going to find is we're going to find f of g of 3, and then we're going to find g of f of 3. So the big deal here is to work from the inside to the outside. Okay, and what that means is we're going to focus on g of 3 first. So we're going to leave the f out here, and then we're going to do g of 3, which means we're just going to plug 3 into g, right? So let's do g of 3 over here. That means I have 3 times 3 minus 4. I don't know why I put that parenthesis on there. That means 9 minus 4 is 5. So g of 3 equals 5. So here's what I'm going to do with that. Now, what I really have is f of 5, right? If g of 3 equals 5, then I can put the 5 where the g of 3 is. Okay, so now I'm going to do f of 5. And that means I'm going to go plug 5 into f of x. So 5 squared plus 2 times 5 plus 1. 25 plus 10 plus 1 is 35 plus 1 is 36. And so you're doing 2 substitutions. You're just starting from the inside, working to the outside. Okay? Let's see how that works with this guy. We're going to start with f of 3. So f of 3 means plug 3 into the function f of x. So I'm going to take x squared plus 2x plus 1 and plug the 3 in. 3 squared plus 2 times 3 plus 1 is 9 plus 6 plus 1 is 16. And so f of 3 equals 16, which means now I'm finding, let's go back to this original statement. Now I'm going to find g of 16. Just replace the f of 3 with the 16. I'm going to do that down here. So g of 16, g of x is 3x minus 4. I'm going to plug 16 in. 3 times 16 is 48. Minus 4 is 44. So g of f of 3. I started out by plugging f of 3 in, getting 16. Then you do another substitution and do g of 16. And the answer to this whole thing is 44. Now, you could probably see where one little boo-boo can really get in your way. So you guys have to be super good detectives here and go back and check your work and be really, really careful if you get these wrong in varsity. I think I have unlimited number of chances on these assignments, so you can just keep trying them over and over again until you get them. Okay, the last question in 2.2 is, it looks something like this, and it's fairly straightforward. This is question number 7 in 2.2 in varsity. And it will look like this. For the function f of x equals 3/2 x plus 1. Find the value of x for which, this is wording directly out of varsity, f of x equals x. And so what's happening here? This is actually really fairly easy. This is a rule. And it's saying f of x is equal to the letter x. Well, we know from this problem, f of x is 3/2 x plus 1. So if f of x is this, right? And we know f of x equals x, then you just take this part, f of x, and set it equal to this part. So the function equals x. And now manipulate it and solve for x. I'm not going to do that on this problem. That is algebra 1, right? The harder part, understanding what these rules are saying up here, is the algebra 2 part. So they're giving you some function notation and then giving you a more educated way of saying, hey, solve for x. So all of this was 2.2. Nope, I'm sorry. Yeah, 2.2. Okay. And so the next section is 2.3. You might want to take a little break and come back and work on 2.3 momentarily, but make a definite section page change in your notes. Okay. All right, so this is 2.3, and this is operations on functions. And these are long, but they're really not hard. The biggest mistake people make is with minus signs, believe it or not. Okay, so here is how a question is going to be worded. It's going to say, let f of x equal x plus 1, comma, g of x equal 3x plus 2, comma, and h of x equal 3x squared plus 4x plus 1, period. Then you're told, write a formula for the following functions. Okay? And don't take the word formula too seriously. Here is what you're being asked to do. F plus h. Just quite literally take function f, which is x plus 1. I would, anytime you have functions that have multiple terms, put parentheses around those terms. It will really help you when you have the subtraction problems. In the addition problems, it's kind of redundant. You don't really need it, but it will help you a lot if you do those for your subtractions. And you're going to add to it h of x, which is 3x squared plus 4x plus 1. Now, if it helps you to drop these parentheses off, feel free to do that. But I'm just going to combine like terms. And that gives me a 3x squared. You should always start with your highest exponented term. I have a 4x and an x to give me a 5x, a 1 and a 1, and I'm adding to give me a 2. And this is the answer to the question. That is the formula that they're asking for. Okay? Now, B is where these get hard because you guys leave signs off and you're not careful. H minus G. You're simply taking function H, 3x squared plus 4x plus 1, and subtracting off G of x, which is 3x plus 2. And the way I wrote it, you should be able to identify that you need to distribute that. If you don't put parentheses around that, you're last term will be wrong every single time. So now just drop off your parens, minus 3x minus 2, and then combine like terms. And we're going to get 3x squared. 4x minus 3x is a 1x. Don't put the 1 on the x when you put that in varsity. And then 1 minus 2 is negative 1. And this is the formula or the rule that they're looking for. All right. So I'm going to work through all these. They may not necessarily, you might be able to figure these out, but just in case you can't, I want to make sure everybody's prepared. So FH, no symbol in between. This means multiply, right? So if I'm taking F was x plus 1, and I'm multiplying by h, which is right in the problem above right here. So that's 3x squared plus 4x plus 1. This means you have to FOIL all this out. So you're going to multiply the x times all of those. So I get 3x cubed plus 4x squared plus x. And then I'm going to multiply the 1 by all of those. And I'm going to get a 3x squared plus 4x plus 1. And then add everything down. 3x cubed plus 7x squared plus 5x plus 1. And that would be my answer. Okay? So multiply. You're getting some experience or some practice again foiling, which is why that was important in the last chapter. D. D and E are very similar to each other. So I'm just going to do D, which is H over F. You're dividing them quite literally. H is 3x squared plus 4x plus 1. And F was right up in the problem above, x plus 1. Done. Can't do anything with that. Just write one over the other one. The next one looks identical to that, so I'm not going to cover that. You're going to see something like, we'll make this E, F plus G plus H. You're quite literally adding all of them together, right? So F is x plus 1. I don't know what G was. G is 3x plus 2. And H is that 3x squared plus 4x plus 1. Add them all together, combine like terms. You guys can do that from there. Actually, I need it later, so I might as well do that. We get a 3x squared. That one's used. 4x, 7x, 8x. And then I have 1, 2, 3, 4. Okay, so that's in there. If you have, and I'm not going to actually do this problem, but you're going to have something like this where you're going to see F plus GH. That means multiply these two together first. Oops, that's not an M. Right? No symbol in between really means an invisible multiplication sign. Remember PEMDAS. You're always multiplying before you're adding, right? And so you have to multiply first, then take the product and add F to it. All right. Another thing you're going to see in here is something like F plus H, F plus H, and then a -3 in here. Well, look and see if you did this anywhere. That was actually the first thing we did. So part A, if I go back up here, part A was F plus H, right? That's what we did right here. So I'm going to try, we'll see, you know how well this worked last time. If I can take 3x squared plus 5x plus 2, actually, this is what I'm going to do. 3x squared plus 5x plus 2. That's what I'm going to actually just take it and move it down the screen. So we're going to just borrow this. This is F plus H. F plus H is that. And now we want to find f plus h of negative 3. So I'm going to take and plug a negative 3 into this function. If you had not already had this answer, you would have to do that first and then do this part second. So we're going to go 3 times negative 3 squared plus 5 times negative 3 plus 2. So now this combines 2.3 operations of functions with 2.2 evaluating functions. Now you're kind of doing both. Remember that exponents here happen before multiplication. So this is 3 times 9 minus 15 plus 2. 3 times 9 is 27 minus 15 plus 2. 27 minus 15 is 12 plus 2 is 14. So the answer to that would be 14. Okay. There's another one that says in this section, f plus g plus h of negative 4. All right. Well, if you recall, we had f plus g plus h somewhere up here. This is E. F plus g plus h was 3x squared plus 8x plus 4. 3x squared plus 8x plus 4. And we're just going to substitute the negative 4 in, which you guys have seen now a million times. So I'm not actually going to finish this up. What I would recommend, though, when you do these in varsity is, let me go over there and show these to you really quickly. So this is 2.2, and I'm going to go 2.3, actually. So operations with functions. You're going to see questions like, let's go down to number 3. All right. Notice first at the bottom here, you have unlimited attempts on these. So I would, actually, this one's, look at these, A through H, they're all just adding and subtracting, multiplying, dividing the functions together. It's not until you get to question, those are the same, 5 now, where they're actually giving you these values to plug in. So I would actually do some of these first. You can do one and submit just that answer and see if you're right, and then do the next one. Make sure you're getting them right as you go. And number 6, okay, same kind of idea. I mean, you've already got the functions there. So don't be afraid to just submit these one at a time and make sure you're getting a section right, because you have unlimited attempts down here, right? So you can do that. All right, that is the end of 2.3. Again, you might want to hit pause here, take a little break, maybe grab some food, come back with a clear mind, ready to do 2.4, or notice the time and just finish the lecture later. Okay, so welcome back. If you took a little break, if you hung in there and you're continuing, 2.4 is composition of functions. Composition or compositions. Let me turn the page. Compositions. Well, the good news is you've actually already done this. But what's different in this section is you now have new symbolism. But I'll show you what that looks like and how you can modify it for your needs. All right, so I want to have you recall that we did something like this, f of g of 2, before, where you found g of 2 and then plug your answer into f, right? We worked from the inside parentheses to the outside. Okay, well, that's exactly what we're going to do in this section, except like I said, there's some different symbolism that you're going to see. So compositions of functions, they utilize a new symbol that you've never seen in math before. And it's a small open dot. And so if you see this, F small open dot G of 2, that's what that would mean. So this is pronounced F of G of 2. That's how you say that in English. Okay, the little dot, the open dot represents the composition. It is not this F dot G, which would be multiplication. Don't confuse those two things. It is not this. Okay? What you're going to do is rewrite it. You're going to rewrite as F of G of 2. These mean the same thing. Okay, and you know how to do this. So you're going to see this in Varsity, you're going to turn it into that and just do that. Okay, so I have a couple examples. I'm going to work through one of the problems that's in there. And this prepares you for some future math later down the road. All right, let's see a problem. This is going to look like this. Let's say, let f of x equal x squared plus 4x and g of x equals 3x plus 4. Find the following. A, f of g of x. B, g of f of x. And then what we're going to do with those is we're going to find f of g of 0, and we're going to find g of f of 2. Okay, so it's important that you find the generic functions first in terms of a variable, and then you plug the numbers in. That's why they come in this order. And if they don't go in this order in Varsity, if you see the numbers first, don't do that. Do the actual functions, these two at the top, A and B, first all the time. So the first thing I want you to do is rewrite. First letter, then a paren, then the second letter, then a paren, then the variable. So f of g of x. Let's go down here and rewrite this one. This one's going to be g of f of x. G of f of x. So it just comes in the order left to right that they fall in right here when you rewrite those, okay? And what that means is you're now going to take g of x, and you're going to plug it into f anywhere there's an x. So this is a lot like way back when you did f of a plus 4, right? Same idea. You're plugging a plus 4 into that function up there. So we're going to plug g of x in the blue box up here anywhere there's an x. In the f of x function. So there's an x here and there's an x here. So I'm going to rewrite this. The x becomes my 3x plus 4. Now, in this function f of x, right, this x is squared. So I have to square that component. And then I'm going to have plus 4 times x, which becomes my 3x plus 4. So I am quite literally taking what's in here, and then that is going into the other function anywhere. Oh, geez, that did not look the way I wanted it to. It is going into this other function anywhere there's an x, and you're substituting that. So here's your x squared plus 4x, right? That's f of x. So the substitution here is generally the hardest part. And if you can do the substitution, then you can do the math. Let's go and do the substitution down below here as well. And I'm talking about this guy. So I'm going to undo some of my highlighting here, if I can. Let's get rid of some of this. Uno momento. All right, so this will help us when we want to do this the other direction. We're going to delete those. Okay, so now I'm taking f of x, highlighter, highlighter, f of x. Maybe I should do that in a different color. F of x in green. F of x, make it green. I'm going to go to g of x now and put it anywhere there's an x in g of x. Okay, so this is going to look like when I do that substitution, I'm using this, but replacing the x. So I have 3. The x becomes what's in green up here, x squared plus 4x. And that's done with that, right? And then I have plus 4 on the end. And now you guys are just going to do the algebra. This algebra down here is much easier in this guy. So I'm just going to distribute. And then I don't even have to combine like terms. That is g of f of x. Okay? Now this guy up here, remember that an exponent on a quantity means that there's that many of that quantity. I'm going to distribute here. Okay, so when I do that distribution, I get 9x squared. I get 12x, and 12x is 24x plus 16. Bring down the 12x plus another 16. And what we end up with is 9x squared. 24 and 12 is 36x. 16 and 16 is 32. And so this is my f of g of x. And this is g of f of x. Okay, let's practice that again on another screen, and then we'll come back to this guy. Okay, so I'm just going to make up 2 functions here. Let f of x equal 2x squared plus 3x minus 1, and g of x equal 12x minus 5. Find f of g of x and g of f of x. So first, let's rewrite. Okay, this guy is going to be f, then g, then x. F parenthesis g parenthesis x. Down here, g f x, so g parenthesis f parenthesis x. All right, and then I like to use this highlighting, and if it helps you to do this, you can, it's not against the law to write things more than once. I know it's not liked by most of my kids, but it's possible. So in this one, I'm going to take g of x. I'm going to take g of x, and I'm going to put it into f anywhere that there's an x. So it's going to go into both of those locations, right? This guy is going to go here, and it's going to go here. So this is going to look like, here's my substitution. I start with the 2. I replace the x with 12x minus 5. Make sure I square that x. Then I have plus 3. And then I replace this x with 12x minus 5. And then I have to bring over the minus 1. Okay, so that's the distribution part. Now, I'm going to ignore the 2 out here for a while and just do this. So that means 12x plus 5, minus 5, sorry. 12x minus 5 times 12x minus 5, which is 12 times 12 is 144. Negative 5 times 12 is negative 60, and I have 2 of those. So negative 60x and another negative 60x plus 25. All of that is now multiplied by this 2 out front. I'm going to go ahead and distribute here. So I have plus 36x minus 15 minus 1. All right, now 244 times 2, or I'm sorry, 144 times 2 is 288x. I'm going to combine like terms here first, minus 120x, and then multiply by the 2, so minus 240x plus 50 plus 36x, and I'm going to combine like terms here, minus 16. All right, one more step. What did I do wrong? I missed something. Did anybody catch it? Anybody? Here's what it is. When I multiplied originally 12x and 12x, this 144x should be squared. So my 288x should be squared. So I have 288x squared. Then I have a minus 240 plus 36x, which is going to give me a 204x, a negative. And then positive 50 minus 16 is a positive 34. And that would be the answer to that. So it's just a lot of algebra, guys. The substitution really isn't that bad. It's just a lot of algebra. All right, let me pull these arrows and things down so we can look at this one. Look at this one a little bit more closely. Look at that. I just flung that around the board. That was kind of funny. All right, let's get rid of these. We're going to delete. All right, and now looking at this new function, we have f of x down here. I'm looking at this guy, right? So I'm going to change my highlighter color. I'm going to highlight f of x in yellow. That's f of x. And I'm going to put it into G anywhere there's an x. So it's going to go right there. And so this is going to look like the 12. Then I'm going to replace the x with everything that's highlighted. So 2x squared plus 3x minus 1. And then bring down the minus 5 from the original function. This guy's going to be a little more straightforward because there's no foiling or anything for us to do. So I'm going to distribute here. 12 times 2 is 24. X squared. 12 times 3 is 36. Minus 12 minus 5. Combine like terms. 24x squared plus 36x minus 17. Okay, so that's the intro to composition of functions. And then the only other thing you're going to have to do with these is evaluate your compositions at a number. So typically you're going to do the composition first and then do the rest. So jumping backwards to the first composition we did here, what you're being asked to do now in section C, I'm down here, is to take f of g and evaluate it at 0. Well, f of g is right up here, and so I'm going to rewrite it. 9x squared plus 36x plus 32. And now I'm going to just plug 0 in where all the x's are. So if I plug 0 in, 0 times anything is 0, right? So this first term is going to have a 0. That's going to go to 0. And so these will go to 0, and your answer here is 32. Okay, that was really straightforward. Then g of f. Again, I already have g of f. It's right here. So I'm just going to bring it down. 3x squared plus 12x plus 4. Now I'm going to plug in a 2 anywhere there's an x. So 3 times 2 squared plus 12 times 2 plus 4. This is 3 times 4, not 6 squared, right? Exponents before multiplication. 12 times 2 is 24 plus 4. This is, I was going to make that a 6, thinking back to what I just said. So this is a 12. I'm going to add these together. It's 28. And 12 plus 28 is 40. And so that's the answer to that. All right, so watch this again if you need to. Pause it, go back and look at stuff. Use lots of highlighters. Lots of highlighters when you do this section. Okay, and this was, again, 2.4. And that's the last section. This is actually the end of the whole chapter. So we're going to spend a bunch of time doing varsity on separate days, doing some other material, and then we'll have a test on all this stuff. So we'll talk about questions in class tomorrow if we meet in person. Alrighty, toodaloo.